Hi everyone. In this video, I want to dive into Entra resilience because as Entra is our identity provider, not just for Microsoft workloads, but for many organizations, all of their various cloud services all use Entra as their identity provider, that they access all these different SaaS applications and PaaS platforms, maybe even on-premises applications. Well, as that entry point and first layer of security, it's getting a greater and greater emphasis. And so with that greater emphasis on identity, it's really important to understand its resiliency, because if the identity is not functioning, well, I can't get to my messaging, I can't get to my voice, I can't get to my email, I can't get to my enterprise apps, my data, the list goes on. And so the resiliency of our identity provider, i.e. Entra, is really top of mind. Now, I did a video a few years ago on what was then Azure AD resiliency. And you can almost think of this as an add-on with some additional bits of detail, some additional data, some of the progress that has happened that was kicked off a few years ago, but now is really cemented at the very core and foundation of what is Entra. Now, to walk through the resilience, I want to walk through our experience with Entra. So I can think of an organization is I have my particular Entra tenant. So my company has its particular tenant. Now that tenant is where all the objects, all the policies, all the metadata lives for my organization, whether they are cloud-born, or maybe their source of authority is something like Active Directory domain services and it synchronizes in there. But all of my objects live within my particular tenant, my particular instance of Entra. Now, when you create your tenant, one of the things you pick is a particular geo. You pick a certain country and that will tell you what your geo is. Now, if we jump over to the portal, we can see exactly this. So here I'm looking at my tenants, but we can see the option here to create a new tenant. Now, when I do this, I'll say, yeah, I want to do an Entra. And you'll notice you pick a country. So right now it's on United States, but pay attention to, therefore, my geographic location is United States. Now, if I was to change this to Canada, well, Canada's geographic location is still United States. If I was to pick somewhere like Denmark, my geographic location is Europe. If I was to pick United Kingdom, we jump around the map a bit, it is Europe. If I was going to pick something like, while I'm down here, Taiwan, you would see is APAC, Asia Pacific. And I could also go and pick something like, well, New Zealand or Australia. And for those, you're going to see the geographic location is Australia. So what this tells me is there are 4 geographic actual regions where your Entra tenant can live. So I pick one of those countries, and what that is going to drive me to is either my tenant is physically going to exist within the geographical boundary of the United States or Europe or APAC or Australia. Now, there's also a potential global type that is very rare, and that's not something I can request. That would come through based on engineering and the type of tenant it is. But there is also something called Go Local. There are particular regions that have some super strict requirements about, for example, where data can live, where it can be serviced from. For example, Japan has a Go Local. And so that's going to change where the services are, where the objects live. Now, in these scenarios, we can think about, okay, so what's actually going on within those different geographies that's going to house our actual tenant? Now, a key point here is Entra ID is now cell-based. You're going to hear the term CeBA, cell-based architecture. And the whole point of CeBA is it's adding resiliency. It provides limits on what is the blast radius of any kind of failure. And what I want to do in this talk is actually dive into what does that cell-based actually mean and how it relates to my tenant. I think that's a really important thing to gain confidence in the resiliency of Entra. So what I can think about is for any of these, so US, Europe, APAC, Australia, what it's actually going to mean is for any of those geographies, there's going to be 4 distinct regions that house the numerous replicas of the objects, of the storage, of the compute instances. You can really think a bit of a 4-legged cell. Now, if there are not 4 regions in a particular geography, then what it will do is use 3 regions and then AZs in one of them because it always wants 4 legs of the cell. So for any of these, it's going to get broken up. And I can think of it as broken up into, we'll go into Azure color. We're going to think region 1 for that geography, region 2, region 3, region 3, and region 4. There's always going to be these 4 legs of the cell. And we'll give a little bit of a line to divide up. I'm going to make region 1 a bit more detailed so I can show you exactly what is going on within there. So we have these 4 legs. So in US, there would be 4 US-based regions. In Europe, 4 based Europe regions. APAC, 4 based APAC regions, etc., etc. Now, within any one of these particular regions, it's going to house many, many cells. Each cell will serve a specific set of tenants, and we're going to get into that. So I can think about, okay, so in region 1, I'm going to draw out cell 1 in detail. So I'm going to think, okay, we have cell 1. So cell 1 would also exist in every one of those other 3. They're all the same. So I have cell 1 here, here, and here. Now, there's also many, many other cells that all exist, for example, within the US. So I'd see a whole bunch of n number of other cells, 2, 3, 4, 4. And this would also have, I'm not going to keep drawing it, you get the idea. They all have multiple sets of these 4-legged cells because every cell exists in all 4 of the regions. Now, again, I'm going to focus on cell 1, one of the cells, just to draw out the content and what goes into it. But imagine whatever I draw in cell 1, there's an equivalent set of services in cell 2, 3, 4, 5. And all of these repeat for all of the different cells that serve the tenants for its particular geography. So US has a certain set of cells, Europe has a certain set of cells, etc. Now, any particular cell serves a specific set of tenants, and those tenants are spread over a specific set of partitions which store the actual objects. So I could think about for a second that I could think, okay, well, at the bottom here, I'm not going to draw all of them, but for any particular cell, it's housing multiple partitions. So each one of these is a partition. So there's many partitions in a cell. And again, it's going to be the same partitions in every leg of that. So they're all the same. So we have these partitions. Now, a single partition will contain many tenants, unless it's a very, very special tenant that is just huge in its scope or huge in its configuration, like Microsoft has its own partition, as do a couple of others. Now, these partitions have many replicas in each region. So it's not just one copy of a partition. There's actually n numbers of replicas. So there's resiliency even within the region for the replica. The exact number will depend on the workload, the tenants, how many large groups. There's certain aspects that do particular things. So my tenant, so if I was going to draw kind of a me, so me, I'm there. I am here. Which obviously also means I'm there, and I'm there, and I'm there. Because what's happening is, remember, this is a full replication mesh. So the objects are synchronized over all of those. So a cell services a specific set of tenants. Those tenants are distributed over a certain number of partitions within there. Now, technically, it is possible to move tenants between different partitions, maybe even different cells if required, based on changes in the workload, based on the behavior. And as changes happen, they get actioned by a primary service, gets replicated to a replica, and then once it's committed, that transaction is considered complete. So I end up with this, and then obviously it synchronizes to all of them, which is how I get this replication mesh. If there was any kind of logical corruption, it gets detected, and the replication progress would be terminated, and those transactions rolled back. So this is just the very, very bottom of the layer. That's just think about, how are the objects actually stored? So, hey, my tenant lives in a partition. My partition is one of n numbers within a certain cell. And hey, that cell, there's 4 copies of that cell over the 4 regions. So how do I actually start talking to these services? Well, the first thing that actually happens is, as a client, I hit a gateway layer. Now, I find the gateway that is closest to me via DNS. So when I query DNS for like the login service, it's going to resolve to the closest instance to me. So if we jump over for a second, if I just go and look at DNS for a second, and here I'm just looking up login.microsoftonline.com. And if we dig into what's happening, well, we can see one thing is it goes to login.mso.msidentity.com. But you'll also notice something interesting, just pay a note. It also resolves to this Akamai DNS record, which we'll get back to in a second. And that's going to resolve to some actual gateway instances that are geographically closest to me. So what's happening here is, yes, the client initially resolves via DNS, but what's going on here is even that DNS is active resilient. The records for all of the login services for Entra are actually hosted by 2 independent DNS entries. Yes, the Microsoft, but also Akamai. So there's resilience from any kind of DNS issue. And what's actually happening here is we talked about these 4 primary regions, but obviously there are many other regions that make up Azure services. So I can also think about there's n number of other regions. And when I think about that gateway, that initial entry point, that gateway layer actually exists across all of them. So think of it as a slice. In every single region, I can think about there's a gateway slice. So in all of these, there are gateway instances. And so as I'm a client saying, hey, I want to talk to login services, what actually happens is I will get resolved to an IP address of the gateway instance that is closest to me. So maybe I'll get sent to this one or this one, wherever it is. This is an independent slice from the cell. So the gateways are not cell aligned. Let's make that really clear. The gateways are a separate slice. They align to a particular physical location. The gateway in this region would be used to service all of the cells. And as we start to dive into more services that make these up, this can go and talk across regions if it needed to, based on how if there was a problem in any particular region's instance of services. So the client resolves DNS. It gets pointed to the IP address of the gateways that's closest to them. And this gateway is an intelligent reverse proxy, which is common across pretty much all of the Entra services. It terminates the TLS connection from the client, unpacks the request, extracts the tenant, and does a lookup of, okay, well, for this tenant, which cell does this tenant live in, so it knows where to route the request to. Once it knows which cell, remember there's 4 legs of that cell, it kind of just will round robin to the next layer, something called the ESTS, that actually gives out tokens. So it's going to go and send the request to a particular instance in the correct cell that can actually go and service the request. So the key point here is Microsoft has many entry points into that Microsoft network. This gateway slice, there are gateway instances in all of those different regions. It's not just the 4 where the cell-based architecture lives, so it's not cell-aligned. The gateways, they still follow safe deployment practices. So they use a ring-based approach to roll out changes. So you can think about a gradually greater portion of the traffic. So an initial change goes to a ring that may only have 2% of the traffic, then 10% of the traffic on the next ring, then 16% of the traffic, and so on until the change is rolled out. So they gain confidence for any change. And that safe deployment practice will follow everything we do as part of this whole story. So resilience is one thing, but obviously change is often a cause of problems. So those safe deployment practices are baked into everything this does. Okay, so the client does a DNS lookup, gets an IP address of a gateway. We know my tenant, okay, lives in a partition in a particular cell when the gateway did a lookup and knows which cell. So what lives between the gateway and the partitions to actually service that request? So the first part of this, and I kind of alluded to it already, is the ESTS service. So that lives in the cell, and I have ESTS. And that's the thing that actually gives out the tokens. And again, the gateways, the ESTS can be spoke to from any of the different gateway instances. And obviously the ESTS lives here, and it can talk to any of them. Everything I'm drawing lives in all of the cells. They're all exactly the same. So you can talk to any of those gateways. Now the ESTS evolved, or Entra now we might call it, secure token service. Now this is a scalable layer. So this scalable layer is made up of n number of compute instances that run the ESTS service. And again, it can vary depending on what is the load at any moment in time. So this is the thing that actually will give out the tokens. Then there's still the partitions down here. So between the ESTS and the actual partitions, there is a directory proxy. And that will actually go and talk to the partitions. And once again, the directory proxy layer, it's made up of this scalable layer of n number of compute instances that can change based on what's required. So both of these live in the cell. Both of these are that cell-based architecture. They have their own sets of machines. They use the cell-based architecture. So although these are part of the same cell, they are a different set of scalable sets. They are independent services. They run independently from each other. A key point when we look at this, and again, I'm not going to keep drawing on every single layer. These are identical. We have the same set of services in every leg of this cell. But if you look at this, every cell is very well isolated. Each leg is very well isolated. A failure in one leg will not propagate to the other legs. Safe deployment practices are utilized as changes are pushed out to portions of the services in each one of those, and then to different legs. So there's not going to be a change that gets sent over all of them at the same time. And this ESTS I've drawn as just talking to its local directory proxy. Technically, for certain types of failures or lookups, it can go and talk to other ones and even ones in other cells. Imagine I had B2B, an external object, something in another tenant. Well, it can go and look up, go and find other cells and do certain types of redirection and communication. But for simplicity's sake here, I'm just going to say, hey, it's talking to its local directory proxy, which goes and talks to the actual partitions. So huge point. We have four-legged cells over four regions that are completely isolated from each other, which really minimizes any kind of blast radius. And with that, the goal here from the SLA is 4 nines. But if you actually look at what's happened so far, most of what's been achieved is actually 5 nines. So if we jump back over for a second, we can look at the historical service level agreements for Entra. You can actually see that most of the time it's sort of 5 nines. There was a little dip one there, lots of 5 nines. And I can even look at my own. So that's the general SLAs. But if I go to the Entra portal and then under identity, go and look at health. And then under health, look at my SLA attainment. I can see my particular tenant and I can hover over that. So I can see I've got 99.998, 99.99, and it will go red if it drops below the SLAs. These are all nice green lines. And then I can see the history of the SLA for my particular tenant. So that's where I can go and view exactly what is going on. So that's a nice thing to go and validate and see what's happening from that resiliency perspective. So super resilient, but there's actually even more to the resiliency service. So if I think about, okay, those four-legged cells are in the 4 regions for that particular geo, lots of resiliency there. There's actually other services that make up Entra for something called a regional STS or ESTSR. Now, these exist in pretty much all of the Azure regions. Now, I'm going to draw it over here as other regions, but realize what I'm about to draw also exists in the 4 primary regions as well. It's just the picture would get a little bit busy. So for these, I can think about there is this ESTSR service, which I'm going to draw as having a nice cache. And we're going to dive into what exactly that means. So this is the same ESTS code. But what you can do as part of the ESTS is have changes in the configuration, which can then think of different config flags that can adjust its purpose, adjust its behavior. And think of this cache as a cache of metadata and certain token material. And what can happen is when there's a request, it can go and check that cache. So what we're talking about here is really other Azure services. So I'm an Azure service, and I'm some kind of resource, and I want a token. Now, what happens here, in addition to the global gateway slice, there's also a regional gateway slice, which is a different set of infrastructure. So it lives within. And again, there's going to be one in this region as well, and that one as well. So Azure services actually do a DNS lookup for the regional gateway, the regional endpoint. So it says, hey, help. It will resolve to the ESTSR, where it can go and give tokens. So this is all locally within the ESTS. And the way it's going to work is this has this cache of the tokens and it proactively refreshes them. But if the ESTSR doesn't have the material in its cache to be able to create the tokens, what it will do is it will go and make a call to the regular ESTS to get the required material, to get the token, so it can go and give these out. But then for the most part, what this means is, A, doesn't even have to talk to the regular global ESTS service, but if there was some kind of global issue, so again, we're starting to sort of very unlikely, well, it can still serve within a certain period of time. So that for up to 3 days, if it's done an authentication on a security identity in the last 3 days, it will still have that material in its cache. It could still go and continue to give out tokens. So the key point here is this regional, this ESTSR, is deployed in all regions. It distributes over availability zones to add to that resiliency. Doesn't rely on this directory proxy or any of that stuff at all. It's also available across all of the Azure clouds. So the different clouds like GovCloud, it's there as well. So I'm drawing this regional in other regions. But again, this does exist in those 4 core regions for whatever that geo is as well. So the request comes in from an Azure resource. So the regional gateway, again, separate slice from the regular gateway, same code, different deployment. Coming from some Azure service or certain special first-party apps. And it will go and use this regional ESTR that has a cache as well. This is why you always talk about use managed identities. Managed identities always use the regional gateway, always use the regional ESTSR. Gets a long-lived token for 24 hours that proactively refreshes at 12 hours. It's why managed identities are so phenomenal. And it's saying I have responsibility for, as a customer, use a managed identity wherever you can, because it gives you a much longer-lived token because it has that continuous access evaluation. It can revoke it if it needs to, so it can have a longer-lived token. And it gives you even more resilience if there were some kind of issue going on with Entra. And so that regional point, actually, we jump over for a second. So I was doing a DNS lookup of login.microsoftonline.com. The regional endpoint, you just stick the region in front of it and then .r. So the West US 3, that just resolves to the regional endpoints. But even there you can see there's an Akamai version of it as well. So again, we always have this resilient DNS service. But this is what happens to your Azure resources. They actually go and look up the regional gateway, and the regional gateway will then let them go and use the regional ESTSR to give out those tokens. So that's really a huge reason that we always love to use managed identities. And they simplify things as well. But from a resiliency perspective and the long-lived tokens, this is huge. Now, if the ESTSR is down in an availability zone, well, then it would go and try the ESTSR in a different AZ within the same region. If all of that fails, then it will go and just use the regular ESTS. So it can do that as well. And as I mentioned, you have this nice 3-day kind of cache going on there as well. So this is still just regular authentication, authorization going on. But then there's another component as well. You've probably heard of backup authentication, or CCS, Cache Credential Service. Now again, the Cache Credential Service is built on the regular ESTS code, but again, you have these kind of different configuration flags. But the big deal here again is it runs on a completely different set of infrastructure, a substrate, from the rest of everything else going on here. So when I draw it, I'm actually going to draw it up outside of this part. So we have this CCS, or again, as we call it, backup authentication. And it too operates on this idea of a cache. So again, it has that cache and metadata, certain signing materials required. But because it's a completely separate set of infrastructure, this now gives me protection if there was some kind of widespread Azure type issue. And what's happening here is the regular ESTS instances of the 4 legs of the cell, they're in constant communication with CCS. When it generates and gives a token out, what it's actually doing is it's pushing that token and the detail into the cache. And that cache is good for 3 days. So what's going to happen if there was some global issue with ESTS for your cell, because remember, that's super unlikely anyway because of the safe deployment practices, blah, 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 blah. But if there was, as long as you have done an authentication for an identity within the last 3 days, which means that metadata, the signing material is in the CCS cache, what would happen is the gateway would say, hey, I can't get to the ESTS. I'm going to flip over to the CCS instead. And then, provided it has had that authentication last 3 days, it will be able to service that request. If I looked at the detail of the sign-in, there's a token issuer type. I would see it set to Azure AD Backup Auth in the sign-in log, so I'd actually see that. Now, this is not going to work for every single type of workload. I mean, that is an important thing to call out here. If we look at the docs, it tells us about the backup auth system. And it says, hey, very commonly for the sort of the Microsoft applications, etc. It talks about other things that will work with the backup authentication. It's listing a number of them there. It will talk about things that won't work. Now, a lot of that is based on, hey, if it's using a client secret, SAML IDP flows, things like that, those will not work with the backup auth. So just important to understand sort of SAML protocol for authentication. So it does talk about when that would not be an option. So it is not everything. But it is many things, and that is growing. And so that's really the summary when I think about that resiliency of Entra. So we think our tenant exists in a certain geo. For those 4 geos, there are 4 regions allocated to house Entra services. And then I live in a particular partition with a number of other tenants. N number of partitions live within a certain cell. Every cell is 4-legged. All of the services, all of the partitions are replicated over those 4 regions. They're all completely isolated from a resiliency and blast radius perspective. Even within the region, there are multiple copies of the partition as well for resiliency. We have this global gateway slice that exists in all regions, and it can redirect to any of the ESTS instances that exist. So if there was a problem for any particular leg of the cell, hey, it can just go and talk to any of the other ones if required. If I'm an Azure or certain other apps, it will actually use the regional ESTS by default anyway, which gives me additional levels of resiliency. If that does have a problem, it can use the regular ESTS. But managed identities, that's a big emphasis on me. When I'm designing my apps and services, use managed identity. It uses the regional ESTS service. I get those nice long-lived tokens. So that's something I can take responsibility for and really improve, again, my responsibility part of that Entra resiliency story. If there was some hideous scenario where all of the legs of your cell were having problems and I couldn't get to the ESTS, remember the DNS is active in 2 different DNS services as well, Akamai and Microsoft, but something happens, well, then there's the backup auth, the CCS, that has a cache. So for any identity that has authenticated in the last 3 days, the gateway, when it can't talk to ESTS, would switch over to the CCS, and it could use its cache to give out tokens while the primary service is restored. Again, that's not everything today, but it is a growing set of services. So my goal of this is hopefully by understanding just how much resilience there is built into this, it can give you the confidence that, okay, because I know as a customer, I can't really add my own resilience for Entra. The protocols it's supporting, the conditional access, all the different services it used, I can't just go and stand that up myself. So I rely. There's a lot of responsibility on Microsoft on this. And they've taken that super seriously when you look at these architectural components they're layering in to make this so resilient. Resilient in the DNS layer, the 4 legs across 4 regions, backup authentication, regional. There's just a huge amount going on here. So you rely on it. You want to have that trust in it, which is why I did this video. If I understand something, I find, okay, if I know what it's doing and how it's doing it, I can get better confidence that, okay, I think I can trust this to handle that aspect of my business. So that was it. As always, I hope this was useful. Till next video, take care.